Hello everyone, I welcome you all to Startup Academy, your online gateway to get success in ISS exam. This academy is exclusively for ISS and we have been covering the topic time series which comes in the third part of our statistics paper 3. So in time series we have completed the measurement of the three one of the out of four we have covered the measurement of three components, which is measurement of trend, measurement of seasonal variation, and measurement of cyclical variation. And the fourth component, which is random component, we'll do it today. There's one method called variate difference method, which we'll use today or we'll learn today. So let us begin. So we have till now learned about trend, cyclical variation, and uh, seasonal variations. So now we'll do measurement of random component. As we all know, our time series is, if we take the multiplicative model, our time series is the multiplication of trend, cyclical, seasonal, and random component. This we have done. This we did by the method of measurement of trend, method of least square, method of averages, moving averages, like that. This cyclical we have done by harmonic analysis method. Seasonal we have done by measurement of by moving average ratio to trend, ratio to moving average, simple average method, and link relative method. These four we have done. And the last component, which is our random component, we use variate difference method. So this will complete our measurement of all the components. So today we'll do variate difference method. What is variate difference method? Suppose we have been given a time series. The time series which is given to us is yt is equals to a naught plus a1 t plus a2 t square with k components a k minus 1 t k minus 1 plus epsilon t. This is our time series, where if we take estimation of epsilon t, it comes out to be 0. Covariance between epsilon I and epsilon j is equals to 0 for all I naught j goes from 1 to small n, the number of terms. And variance of epsilon t is sigma square. So these are the assumptions that we take of the model of our time series. These are the similar assumptions as of econometrics. So these are the assumptions that we have taken. Now we have to calculate the variance, which is this sigma square. Instead of sigma square, let us write V. We don't know what the variance is, so V. So we have to find out the variance of this method. So there is one forward difference we denote it like triangle. So forward difference raised to the power k of yt is nothing but forward difference k raised to the power k epsilon t. Now what is forward difference? This we will learn in the numerical analysis paper. For now, I'm telling you, if I say forward difference of yt, then it will be yt minus yt minus 1. So this means that this value minus the preceding value of the same term. Okay, so now we'll take, and there is one more, this e. If I say e of yt, then this means yt plus h, where h is a interval of differencing. So these are the two things that you should know for this. And one more thing, that 1 plus 1 plus forward difference is equals to e. This is also one of the results that we'll be using here. So we know that this delta k raised to the power k epsilon t can be written as e minus 1 raised to the power k epsilon t, right? Now I will open a minus b raised to the power k. This I will open this. So I will be getting 1. I will be getting e raised to the power k plus kc1 e raised to the power k minus 1 plus kc2 e raised to the power k minus 2, and so on up till minus 1 raised to the power n, and outside it is epsilon t. Sorry, not n, it is k. And alternatively on the odd sides it is minus plus like that. Okay, so if we take epsilon t inside, so e raised to the power k epsilon t, I said e raised to the power k yt would be t plus h. So here the interval of differencing is k, so it will be epsilon t plus k minus kc1 epsilon t plus k minus 1 plus kc2 epsilon k t plus k minus 2 up till so on till minus 1 raised to the power k epsilon t. So this will be our value of delta k et. Now if we take estimation of this, estimation of delta k yt is equals to estimation of delta k epsilon t. Now we assumed that estimation of epsilon t for all t goes from 1 to n is 0. So this will also be equal to 0. So we get hence estimation of delta k epsilon t is 0. Now variance of delta k yt can be written as variance of delta k epsilon t. Now variance of delta k epsilon t can be written as estimation of delta k epsilon t whole square minus estimation of delta k epsilon t. So this term would be equal to 0 from this equation. So we are left with estimation of delta k epsilon t whole square. It will be nothing but estimation of, we'll take the values of delta k epsilon t, which came out to be epsilon t plus k minus kc1 epsilon t plus k minus 1 plus kc2 epsilon t plus k minus 2 up till minus 1 raised to the power k epsilon t. This was the term, and here we have to take the estimation. If we take the estimation of this, we will be getting whole square. This will be whole square. So if we take the estimation of this, so estimation of whole square will give us v as well. So I'm directly writing the result. So it will be variance of delta k y t is equals to kc0 kc0 whole square plus kc1 whole square plus kc2 whole square up till kck whole square raised to and v in the multiplication. So if we take summation of this will be nothing plus 2k ck into v. So our value of v cap or v predicted would be variance of delta k yt upon 2k ck. Here this is c means combination. So this is our variance that we have calculated. Now we'll do the steps involved in this process. So the steps are as follows. First step is draw the difference table like suppose we are drawing the difference table. First would be t, then yt, then delta yt, then delta square yt, and up till whatever we need. This would be our table. Okay. So first we have drawn the table, difference table. Then the second step would be that we have to find the variances with respect to k is equals to 1 and k is equals to 2. If k is equals to 1, then v cap would be variance of delta yt. Since k is 1, so it would be delta raised to the power 1 only, and 2c1, which will be nothing but variance of delta yt upon 2. 2c1 is 2 only, and this is 1, and v2 would be variance of delta raised to the power 2 yt upon 4c2. So it would be variance of delta square yt upon 6. So we have calculated v1 and v2. The third step involves if v1 and v2 do not differ significantly, then either of them can be considered as variance. Either v12 or v2 cap can be variance, else find v3 cap. So for v3 cap again, v3 cap would be variance of delta cube yt upon 20. So then we'll uh, we'll check for v2 cap and v3 cap. If they do not differ significantly, then neither of them can be considered. If they differ significantly, then we'll find v4 cap, and we'll keep on finding v variances until two simultaneous or two continuous variances comes out to be do not differ significantly. So this would be the method. And how would we check that if they differ significantly or not? For this, our O. Anderson considered a study, took a study under consideration, and he took the he had taken out one test statistics which is known as uh, very different test statistics. So the test statistics is RK. If RK is equals to VK minus VK plus 1 upon VK into HKN, if this goes to normal 0 to 1. So we have to find RK, where VK and VK plus 1, you know that these are the variances of K at term and K plus 1 at term, and HK plus 1, HKN is a function of K and N. So if this RK is greater than 1.96, then both of them uh, differ significantly at then Vk and Vk minus 1. It is minus 1 or plus 1? It is plus 1. Vk and Vk plus 1 differ significantly at 5% level of significance. Otherwise, not. So, in short, I'm telling you, if we have calculated V1 and V2, we'll find out RK, which is V1 minus V2 upon V1 into HKN. In the question, HKN would be given to us, and we'll see that if RK, modulus of RK comes out to be greater than 1.96, then these two differ significantly and any of them can be considered as a variance. If not, then we'll calculate V3 and do the same for V2 and V3 again. And we keep on repeating the process until we get our final answer, whether they differ significantly or not. So this was the method. This was the only method that is required to be done for random component analysis. And if you still have any doubt, then you can ask in comment section or in our WhatsApp channel. Relevant doubts will be answered. Many of you have been questioning, have been sending us your doubts and queries, which gives us the view that you have been learning via videos, and keep on watching the lecture videos regularly. And if you have any doubt in the previous part as well, you can ask us anytime. So, all the best and keep on working hard.